Hi everyone, welcome back to the channel. In this video I'll focus on the displacement diagram or graph for chems. So before I start with this question, I just want us to look at the types of follower motions. We have three different types of follower motions, as you can see them here. We have the uniform motion, sometimes called the constant velocity motion. So this is the mostly used motion, and we also have the simple harmonic motion. We have the uniform acceleration and retardation motion. So these constructions here, these lines here, they are part of the construction for this curved line. All right, you can only get this line if you do this construction, right? But we'll get into this as we go through this question. And obviously same thing applies to this type of emotion. For you to get this curved line, even though they look similar, but the construction is different, right? Okay, so I'll start with the question. I'll read the instructions. We are given a starting point, which is point B for the displacement diagram. Remember, in this video I'll only focus on the displacement diagram, right? I'll not draw the chem, I'll only focus on the diagram. Okay, so this is the starting point, which is point B, and we have the motion of the chem here. So they're saying here the chem imparts the following motion to the wedge-shaped follower. It rises 26 millimeters over the first 45 degrees with uniform motion, and it dwells over the next 30 degrees. All right, so it means whatever that we'll draw for this point, it's something like this. All right, but I'll explain that part. And it rises a further 26 millimeters over the next 90 degrees with a simple harmonic motion, which is this type of a motion. And the next point, it remains constant for the next 15 degrees, right? It means there is no change there. The last point, it returns to its original position with a uniform acceleration and retardation motion. So it means at the end of the diagram we'll have something similar to this curve here. Okay, instructions: draw to a rotational scale of 30 degrees equals to 8 millimeters and a displacement scale of 1:1, the displacement graph for the required motion of the chem. So this is the motion here. Lastly, we have to indicate the rotational scale of the displacement graph, which is the scale here we are given, which is 30 degrees equals to 8 millimeters. So now the question is, how long is the graph and how high is the graph? All right, it's simple because we are given everything here. All right, so how long is the graph? It's simple. We'll just look at the scale, the rotational scale. We are given that for every 30 degrees, obviously we'll have a distance of 8 millimeters. So it means we'll have to multiply this 8 by 12, which is 96. So it means the distance will be 96 there. I'll just draw a construction line and I'll just measure 96. 96 is right there. All right, okay. And then now the question is, how high is the graph? So now I know that it will start here and it will end here. So just draw those vertical lines. Okay, so now how high is the graph? I'll have to go back to the motion of the chem. So from the starting point, obviously the chem, the follower will rise 26 millimeters over the first 45. So it means we have 26 millimeters. All right, and obviously it will dwells, so it means it remains constant for that period. Okay, and then it rises a further 26 millimeters, so it means it will rise again for 26 millimeters. I'll just write that down. Okay, over the next 90 degrees with blah blah blah. Okay, it remains constant for the next 15, so it means here it will dwell for 15 degrees, and then the last point, it says it returns to its original position. Remember, the original position is this one, so it means from here it will go back to the original position. So now the total height of this graph, it's 52. Why is it 52? It's because, remember, we had the 26, which is the first rise, and then we had another 26, which is the second rise of the follower. All right, so it means it's 26 plus 26, which is 52. Okay, so I'll just measure the 52. So that's how you get the height of the graph. All right, so I'm just drawing a rectangle here in light construction. So obviously our displacement graph or diagram will be within this rectangle here. I hope it makes sense. Okay, and then from here I'll have to divide this length into 12 equal parts. All right, okay, so that I can label all the points at the bottom there from 0 degrees to 360 degrees. Okay, so for you to divide this line into 12 equal parts, you can just draw a line at any angle, and then you have to divide that line into 12. Right, so I can use my compass there. So even the gap or distance of your compass doesn't matter as long as it's equal all the way. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I'll just extend that line to the last point. So I'll have to connect this last point with this point here. Okay, so just draw a line like that, and then from here it means I'll have to drop these points down to this line here. But obviously the lines that I'll draw here, they'll have to be parallel to this line here. So it means I can use my set squares, or I can even use my t-square there. So I'll take my t-square and my set square. I'll just make sure that it aligns with this line here like that, and then put my t-square there. So from here I'll just slide my 30 by 60 all the way to the last point. So obviously I'm drawing the parallel lines, so just quickly draw the lines, and please make sure that your t-square or the other set square that you've put here doesn't move. So you must press it down against the drawing board. Okay, so obviously I'm done with the lines. So that's how you divide a line into 12 equal parts. All right, so obviously here I can just mark those points because I'll have to draw vertical lines from those points now. All right, okay, so from here I'll just draw vertical lines like that. So obviously the parts now are equal, so please use the same method to divide this rectangle into 12 equal parts. Okay, just like that. Okay, so from here at the bottom I'll have to obviously label those points from 0 degrees to 360. So I have 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. Okay, so now since I have all the degrees there, so it means now I can start constructing the diagram or graph. So I'll start with the first point there. So obviously it rises 26 millimeters over the first 45. So I will just measure 26 here. 26 is right there. Okay. They're saying over the first 45. Remember, we have 0 to 30, and then 45 will be between 30 and 60. All right. So obviously this gap here, it's 8. So half of 8 is 4. So I'll just measure 4 there, just to draw a vertical line. So this is the 45 period, 45 degree period. So it means from 0 to there, it's 45. So it's this 45, right? Okay, so the height, remember, is 26. So it means I'll just mark a point there, like that. Then it means here I can just draw. Remember the motion, it's a uniform motion, all right? So it means I can just draw a straight line. So it's this type of a motion, all right? Uniform motion. So I'll just draw a straight line from 0 there to that height. Okay, and then it dwells over the next 30 degrees. So since it's 30, it means from the 45 I'll have to add 30, which is 45 plus 30, it's 75. 75 is between 60 and 90. So it means here I'll do the same thing. I'll have to measure 4 millimeters just to get the midpoint of this part here, all right? Because that's where the follower will end. So it dwells, so it means it will move horizontally. So I'll just draw a line to there. Remember, the motion didn't change, it's the same motion, it's uniform. Okay, and then from here what will happen, it rises a further 26 millimeters over the next 90 with a simple harmonic motion. So now it means I'll have to do those constructions for me to get something like that. So for the next 90 degrees, so remember, from here to here I'll have 30, 60, 90. So 90 will be between 150 and 180. I hope it makes sense. So I'll mark a point there and draw a vertical line. And remember, they said it rises 26, and that 26 is that line. So it means my simple harmonic will start here and it will end where? There. All right, so my focus is on this section here. Let me just highlight at the top there. It starts here and it ends there. All right, this is simple harmonic, so I must have something like that. So when it comes to a simple harmonic construction, so I'll just look at where it starts and where it ends, right? That vertical line. So it means I'll have to mark a midpoint for me to draw the semicircle, right? So I'll start with the semicircle. We always start with the semicircle. So as long as I know that it starts here and it ends there, so it means I'll have to find the midpoint of this distance, right? Okay, so 26 divided by 2 is 13. So I'll have to mark a point there. This is the midpoint. That's where I'll put my compass to draw the semicircle, right? Okay, I'll just put my compass there to that point. It must go straight to there. Okay, something like that. And then I'll have to divide the semicircle into 6 equal parts. So since I'm dividing this semicircle into 6 equal parts, it means even here for this vertical lines I must have 6 parts, right? So if you have 6 divisions here, I'll also have 6 divisions for the vertical lines. Okay, so I'll just draw the division lines there. So remember, all these lines are light construction. They might be dark right now. It's because obviously I just want you to see the constructions. So just divide the semicircle quickly, like that. Okay, so obviously I have those points here. I have 6 points, so I'll focus on those points. Okay, okay, I have those divisions. Remember, even here I'll have to divide because for now I have 1 2 3 4, so it means here I must have 2 and also here 2. So I'll mark there 4 millimeters and also here 4 millimeters, and then you can draw those vertical lines. So it means now I have 6 equal parts here as well, just like the semicircle. So 1 2 3 4 5 6, right? Perfect. So I'll start here. Obviously the simple harmonic, it starts here, so our first point is there, and then our next point, it's this point. It means I'll have to project all these points to the specific line. So for this point it will go to the next line, just like that. I'll mark a point there. Okay, the next point there, it will go to the next line. All right, just like that. I have a point, and then that point will go to that line. So you just follow those points and the lines. So it means I have a point there. Okay, for that point I'll have to project it to this line there. Okay, mark a point there, and also that point there, it will go there, mark a point, and then the last point of the semicircle, on the semicircle obviously it's there. All right, so now it means here I'll just draw a nice and neat curved line using my French curve. All right, okay, so I'll just use my French curve there just to connect the points there. Something like that. So this is the simple harmonic curve. All right, as you can see, it's the same as that one there. Okay, so that's how you construct the simple harmonic. As you can see, it starts here, not at the bottom there. So it will depend on whatever that you have there. So you just follow the instructions because they tell you where it starts and where it ends, right? Okay, so now I'll move to the next point. So it's this point here. So they are saying here it remains constant for the next 15 degrees. So it means here I'll have a straight line all the way to 180 degrees. So I just draw a horizontal line there. So you must understand the terms like constant, remain the same, it dwells. So those are the same concepts that they mention. All right, so obviously here it's constant up to there, because from here to there it's 15 degrees. Okay, so what happens next? Let's see. It returns to its original position with a uniform acceleration and retardation motion. So it's this type of a motion, right? So it means I must have this construction somewhere. Okay, so now obviously it will start here and it will end way down there. All right, so when it comes to the uniform acceleration and retardation motion, it's simple. You just connect the starting point with the end point. All right. Okay, so I'll just draw a light construction line there. Okay, so because I have 6 divisions here, it means I'll draw a line going up here and mark 6 points, and then I'll just project those points to this line here. I'll do something like this on the side just to have 6 points here. Why? It's because even here I have 6 divisions. It's 1, 2, 3, 4, 5, and 6. All right. So I'll just draw a line going up at any angle, and then I'll mark 6 points on that line. So I'll just take my compass there. So it's 1, 2, 3, 4, 5, 6. Okay, and then the last point I'll have to connect it with that point there. Alright, and then from here I'll have to draw parallel lines. Alright, so I'll align my set square with that line and put the other one next to it, and then I'll just slide this one, and then I'll just draw lines going in like that. Okay, just like that. Okay, so as you can see, obviously I have those points there. Now I'll have to project those points to the center line. This is the center line in the middle, so I'll just highlight that line. Okay, let me just zoom a little bit. Okay, and then from there I'll just project all those points to that center line like that. This must connect with that one in the middle like that. Okay, so now I have points here. So the first point is there, the second one, the third one, the fourth one, all the way down there. All right, and then from there what you have to do is I'll just project this to that point. Already I have a line, and then same to there, and then I'll show you what to do next. So this there, this point there, because that one already we have a line there, and then I move to the last point. I'll project this to that point, and this point. So I'll just draw lines there to the center line, just like that, and then that's it. So now I'll have to mark the points. Remember, I'm trying to draw this curve. All right, so I'm here, so I'll move to the next line. So where this line touches that line, I'll mark a point. All right, and then I'll move to this next line. So where this line touches that line, I'll just mark a point, and then I'll move to the next line, which is the center line. All right, so here I have that line where it touches the center line, it's a point. So it means from here I have that curve to the center there. All right, and then I'll just continue, do the same thing. Where this line touches this next line, I'll mark a point, this line, a point, then back to 0 there. Okay, so obviously it means I was trying to find those points here. So now I can just connect those points using a French curve. All right, so I'll just use the French curve. Then here I think it's gonna be a straight line. just like that. So this is the complete displacement diagram. As you can see, I have the simple harmonic motion from here to there, and then I'll also have a dual period there, and I also have the last part, which is the uniform acceleration and retardation motion, right? And then the first part, it was the uniform motion. All right, so now I will have to indicate what, remember the instructions. Now I'll have to indicate the rotational scale of the displacement graph, so I'll just type it there. Okay, let me just draw the guidelines. And remember, I have to label the graph displacement. So I'll just print the displacement graph, and I'll have to indicate the scale. So scale is 30 degrees equals to, remember we are given the scale there, it's equals to 8 millimeters, and then the millimeters can be in small letters. All right, just like that. So this is the complete diagram.